All right, where does the demand equation come from? All right, so I have a revenue function, which is a quadratic function. So if I call that R of P, revenue based on price, is, and if I multiply this, it would be minus 2P squared plus 276P. And so I think the price should be $69. All right, but let's verify that. I'm kind of doing this in my head. And let me show you quickly how I did this in my head. Because I look at this quadratic function as factored. And if I set it equal to 0, P equals 0 is one root of that equation. And if I set this equal to 0, P would be half of this number, 138. And so my revenue function looks like this. It's a quadratic, upside down, and the midpoint between 0 and 138 is 69. So that's my prediction, $69. But let me, just for sake of completeness, let me do this the more conventional way and see if we get 69. So I like to do it this way myself personally. You may or may not be very comfortable with that. So we could say, well, let's find the vertex, and the vertex would be well, P instead of X. P would be minus B over 2 times A. All right, so A is negative 2, B is 276. Minus B over 2A, the negatives will cancel, and I get 276 divided by 4, and I think that is 69. So 276 divided by 4 is 69. There we go. All right, so that should be the price we're charging. Now, it seems, yeah, there we go. So let's see what we got. The demand, how many rooms would they rent out? Okay, so the demand is up here. So Y would be minus 2 times 69 plus 276. And I think that would be 138. 138, so that's the number of rooms they would be renting out. All right, so it looks like, and I'll clean this up and write out the answer, but the price they're charging to maximize revenue should be $69. And by charging $69, they would rent 138 rooms. They would have a lot of vacancies, wouldn't they? Okay, well, that's the way it goes. It may not be the most efficient to charge a price that fills all your rooms. It may feel great because you got your business is jam-packed, your hotel's jam-packed, but you may make more money by raising the price, but you can't raise it too far. If you raise it too far, you're going to start losing money. So it looks like 69 is about right here. And if I charge $69, we could rent 138 rooms, and we can calculate that the revenue there. So let me see. Let's write the answer out then. All right. So by charging $69 per room, they should rent 138 rooms and earn a maximum revenue, and I think it's okay to abbreviate maximum revenue of whatever that is. So 69 times 138 is $9,522. All right. Now remember we said if they charged $38 and filled all the rooms, 200 rooms, they would earn $7,600. Well, unfortunately for us, the consumers, they do need to raise their price. And by raising it to the right amount, they can pull in $9,522. Now, if you were to add $1 to this, let's see, if you added $1 and charge $70, then you would rent 136 rooms. So 70 times 136 is very close. It's 9,520. But by raising the price from here, this is their optimum, this is their maximum. If they raise the price by $1, they would actually lose $2 in revenue, which I think is kind of interesting. And it goes from there. It actually gets more extreme. If you keep raising the price, that really drops fast. And also if you lower the price, that revenue starts dropping fast too. So, all right, this was not meant to be a terribly realistic problem, but it has some realism to it. And it is a fact that as a business owner, you can either charge too much or charge too little. There needs to be a middle ground there. When there's competition, and the competition will modulate the demand such that there is an optimum price there. And that basically is the essence of capitalism. In that sense, how prices communicate our wants and needs, and so that things get kind of evened out. All right. Well, there are two examples of quadratic functions. I have more in my book, and but I like these. They're pretty classic. Unfortunately, most things in life are not quadratic functions. In order to maximize or minimize or optimize the function, we do need methods of calculus. It's only with the quadratic functions, which have this nice, wonderful symmetry, that we can figure out the optimum point without calculus. So it just gets your feet wet into that and into mathematical modeling. So at least you have some idea of what people could do with calculus on a more grander scale. And people do use calculus for those purposes too. So, all right, well, that's that topic.